So remember, lines are focused on a specific point and a specific direction vector, okay? So hopefully you're getting a little bit better at extracting the point and the vector. So for this guy here, the point that you know for sure is 1, 4, 0, and the direction of this vector is, whoop, computer's wigging out, there we go. The direction is given by the bottoms here. So this is a 1 and a 1 down low. So -2, 1, 1. And over here, for this guy, you have a point of 2, 1, 2, and a directional vector of -3, 4, -1. Okay? So if I have two lines, okay? If I have two lines, the whole focus is somehow this is embedded into a plane, okay? That plane holds both of those lines, and I need to get the normal vector that shoots out of the plane, the pen that shoots out of the book. Well, again, to do that, do the cross product. So, I, J, K, I, J, -2, 1, 1, -2, 1, -3, 4, -1, -3, 4. And shooting out of that book is the normal vector here, which is 5, -5, -5. Or you can reduce that to 1, 1, 1. Okay? Again, the pen shoots out or the pen shoots down, above or below. It's the same normal vector if you orient it. Okay? So if I have the normal vector, and now I need, what else do I need? If I have the normal vector, I should be good, except I just need the point, a point. Do I have any point out there? Is there any point in my plane that I have? Yes. You can use this guy or this guy. It does not matter. So I'm going to use this point, and I now know the normal vector here, so I can write my plane. Okay? So again, my plane then would be, your whole goal, if you like thinking of the definition, is x minus 1, y minus 4, z minus 0, crossed with 1, 1, 1 needs to equal 0. That's the whole definition. Every vector in the plane dotted with the normal vector has to be 0 for orthogonality. And that gives me x minus 1 plus y minus 4 plus z minus 0 equals 0, which is x plus y plus z has to equal 5. There's your plane for the first question. Now, some of you, if you did not reduce with that -5, -5, -5, your answer would have looked a little bit different. But if you divided by that -5, it would have reduced down to the same. Okay? That's the first question. I'm going to do the second one now. It says the plane passes through this point and is perpendicular to the plane, blah, blah, blah. Okay. So let me just kind of draw an orientation of this. Here's the plane I want. This is the plane I want. And I have a couple points in it. Okay. I have 3, 2, 1. And I have 3, 1, -5. So I have those 2 points. And I always orient a plane by shooting it directly out, which means it's normal. And this plane is perpendicular to this other plane. So this other plane, if this, let's say this is directly flat, left to right, then my other plane would look that way, okay, directly up and down. And what do you notice about that plane there if I slide it over? Is the normal directly in line with that plane? Yes. So the normal lines up directly with that plane. So think about that for a moment. So hopefully you're okay with that n vector there lines up in that plane. And if I shoot out of this plane, the green plane, I can shoot something out of that being its normal. Oh, oops. Oh, whoops. Let me change highlighters to a normal pen. There we go. Shooting directly out of this plane is another normal vector. And let me ask you this. If I move this plane, so we have this green plane has the black plane's normal vector. But if I slide the plane down, what do you notice about its normal vector? It's in the plane that I want. If you have two vectors in a plane, you can shoot them out with the cross product to get the third vector being the normal vector. I just said a lot of different things, so let me try and re-summarize it. Okay. Let's get this vector first. That vector there, I'm going to call that u. And doing some subtracting, I get that. Okay? And this normal vector here, n1, for the green plane, you already know it because I already gave you the equation of that plane in the problem. So then this is 6, 7, 2. That's the direction of the normal vector of that green plane. Now, the red vector is in the plane I want. That purple vector is in the plane I want. If I have two vectors in the plane I want, so I have the purple and the red, if you cross product them, what's going to come out of that cross product? Boop! The blue vector, which is the normal one. So let's cross product to get blue normal. Okay? So ij, k, ij. From here, a lot of the math should be okay for you guys. It's more the concept of how I oriented planes using different colors to help you see which vector is in the planes that you have and the planes that you want. So when I cross product this, I get -2 plus 42 is 40. And I get -36. And I get positive 6. Make sure I did the math right on that one, which I did. Can you reduce it if you wanted to? Yeah. So if you wanted to, you could reduce this. It looks like at least by 2. You could drop it to 20, -18, and a 3. So this is important. I have my normal. Okay. Now I just need a point. Do I have a point? Do I have a point? Because remember, plane, for a plane, you need a point and a normal vector. Well, it gave you 2 points to begin with. So let's use the point 3, 2, 1, and the normal here of 20, -18, 3. And you can say 20, x minus 3, minus 18, y minus 2, plus 3, z minus 1, equals 0. That's the standard way. You can go get the general way. I care more about, because conceptually, you understanding the red vector. If I ever give you 2 points, get the vector out of them, because most likely you're going to need that. And then hidden in the problem was that purple vector, which lined up perfectly in the black plane which you wanted. But the whole thing is you needed the blue vector, and you didn't have that. And the only way to get the blue vector is if you have 2 vectors already that you can cross product. So that's a good question there. And this next problem is very similar to it. Okay? So the way I'm going to look at it is, I have a plane that I want, and that plane, let's draw the axes first. Here's the x-axis. And let's say I have this plane here. It's not drawn to scale at all, but I have a point and a point, a 1, -2, -1, a 2, 5, 6. I'm not reading much into the problem yet, but I'm going to go get a vector out of this. Let's see. 2 minus 1 is 1. 5 minus -2 is 7. 6, that is also a 7. Okay, I got one vector. Now, the whole idea on this problem is it says the plane goes through those 2 points. Boom, I already got a vector. This, sorry, looks like a 4, but it is vector 1, 7, 7. Okay, and it's parallel to the x-axis. Okay, parallel to the x-axis. This is kind of an interesting thing. There are many planes that are parallel to the x-axis. What does it mean to be parallel to the x-axis? That's what you have to kind of understand with this. Being parallel to the x-axis, let me draw you a couple versions that are parallel. Straight up and down, that'd be parallel. Okay? The whole idea of being parallel is any guy that I have does not hit the x-axis. If I'm parallel to the x-axis, I cannot hit the x-axis. So if I cannot hit the x-axis, what does that mean? All of these planes that I drew you, imagine them kind of coming out of the board, just like the x-axis does. So if I had this x-axis, let me highlight it as a vector, it is in that blue plane. It's in that slanted blue plane. It's in the red plane. It's in that plane. In fact, it's in every single plane that is parallel to the x-axis. So this vector, its orientation is coming out 1, 0, 0. The green guy is a vector in the plane, and this purple guy is a vector in the plane. If I have two vectors in the plane, I can cross product them to pop out the normal vector. If the normal vector's popped out and already have a point, you can solve this problem just like the one that you did on the previous page. Okay? And if you're curious about that answer, for that one there, you get y minus z equals -1. If you notice, there is no x in this equation. There's no x in this equation because there's no x-intercept. So being parallel to the x-axis means you do not hit the x-axis. Think about that in 2D. If I'm parallel to you in 2D, I do not hit you in 2D. So in 3D, it's the same. If I'm parallel, I cannot hit you. Okay? So there's no x-intercept, so there's no x component in this one. So I have y minus z equals -1. Okay? So your homework for tonight is on page 790. EOO means every other odd. So that would mean 1, not 3, but 5, not 7, but 9, not 11, but 13, and so on, so on, so on. So try those out. And then notice 49 to me is important. Okay? So I want you to also try out 49. And that's why I circled that one. So 1, 5, 9. I got myself confused. Let me just tell you what these are again. 1, 5, 9, 13, 17. Huh. So I don't know why I said 1 through 19 every other. Let us do... Yeah, that's fine. So 1, 5, 9, 13, 17, and then the rest. Okay? There you go.